Hey there. Ready to go meta on AI with me today? We're diving deep into some research that suggests large language models, those things that power chatbots and predictive text, might be developing a way to look inward.
That's right. It's called introspection. Not introspection in the human sense, of course, but the possibility of LLMs being able to examine their own internal workings and predict how they'd behave in various scenarios, all without being explicitly taught to do so. It really challenges how we think about intelligence emerging from these models.
Okay, let's unpack this for our listener. You and I both know a thing or two about AI and machine learning, but this research gets pretty granular. Imagine having access to the source code of an LLM, but instead of reading it directly, you're asking the LLM itself to tell you what it would do if you changed a variable or fed it a specific input. That's kind of what we're dealing with here, right?
You're spot on. The researchers designed these clever experiments with a focus on self-prediction. They essentially asked one LLM, let's call it Model 1, to predict its own responses to certain prompts, focusing on specific aspects of its behavior. They then compared Model 1's self-predictions to those made by another LLM, Model 2, which had access to Model 1's responses but hadn't gone through the same introspection training. Think of it like giving two mechanics the same engine problem. One gets to diagnose it by listening and feeling the engine itself. The other just has a repair manual based on that type of engine.
So Model 2 is like our mechanic with a Haynes manual, just working off of general knowledge and observed patterns, while Model 1 has that direct line to its own thought process, so to speak.
Exactly, and this is where it gets fascinating. Across a variety of models, including the very capable GPT-4o and Llama 70B, the self-predicting Model 1 consistently outperformed the externally trained Model 2. And we're not just talking about a small margin here. The accuracy difference was significant enough to suggest there's something more going on than just pattern recognition from the training data.
This is already making my head spin a bit. We're talking about LLMs potentially having an internal model of their own decision-making process. It's like they can simulate how they would respond to a prompt before actually responding. But before we dive into the implications of that, let's ground this for our listener with some concrete examples. What kind of behavior properties were the LLMs predicting about themselves?
The researchers tested a range of tasks and behavior properties to assess this self-prediction ability. For example, they used prompts like completing sentences from Wikipedia, where the LLM had to predict whether its response would start with a vowel, or continuing sequences of countries or colors, predicting if its output would have an even or odd number of characters.
So pretty granular stuff, designed to see if the LLM could accurately anticipate very specific aspects of its own output. It wasn't about getting the right answer in a general sense, but rather about demonstrating an awareness of its own tendencies at a micro level. Did they also look at how confident the LLMs were in their self-predictions? I mean, being right is one thing, but knowing when you're likely to be right is a whole other level of metacognition, isn't it?
You're exactly right. It's like the difference between a weather forecast that says 80% chance of rain and one that just says might rain. The researchers called this calibration. They examined whether the LLM's assigned probabilities to their predictions actually matched the frequency of those outcomes when they ran the prompts for real.
So a well-calibrated LLM would be more like, I'm 60% sure my response will be blue, and then blue would actually be the answer about 60% of the time.
They weren't just making lucky guesses, they had a sense of how reliable their own thought process was in different contexts. That's precisely what they found. The self-prediction models were significantly more calibrated than the externally trained models. This suggests a deeper level of self-awareness than we've previously observed. They weren't just matching patterns, they were estimating the likelihood of different outcomes based on an internal model of their own capabilities.
This is already blowing my mind, and we're just getting started. But this next part is where things get really interesting for me. The researchers didn't just stop at observing this self-prediction ability. They wanted to see if they could shake things up a bit, see how adaptable these LLMs were.
Right. They designed this really clever experiment where they took that self-prediction trained Model 1 and fine-tuned it on a new set of responses. Not just any responses, though. These were generated by a completely different LLM.
So they basically forced Model 1 to incorporate some new personality quirks from this other LLM, like teaching a jazz musician to play a little bit of country. Did it mess with their groove, so to speak?
That's a great analogy. And you're right, it did change its behavior, at least to some extent. They called this modified version Model C. And remember, Model C was never explicitly trained to predict these new behavioral patterns it picked up.
Okay, so Model C has its original training plus this new flavor from another LLM mixed in.
Right.
What happened when they tested its self-prediction abilities? Did it freak out? revert to its old habits.
Neither, actually. It adapted. And this is where it gets really meta. Model C actually got better at predicting its modified behavior than it was at predicting its original behavior as Model 1. It's as if it could introspect on these newly acquired tendencies and adjust its self-understanding accordingly.
Hold on, let me make sure I'm following this. We're saying that by being forced to mimic another LLM, Model C didn't just parrot those new responses, it actually integrated them into its internal model of itself. It's like it went through a weird AI adolescence, tried on a different persona, but then figured out how to incorporate that experience into its sense of self. That's incredible.
It is incredible, and it really challenges our assumptions about how these models learn and adapt. This isn't just about memorizing patterns anymore. It's about developing a dynamic representation of their own capabilities, one that can evolve with new experiences and information.
This is light years beyond the basic chatbot stuff. We're talking about LLMs that could potentially monitor their own learning process, identify their own biases, maybe even suggest ways to improve their own performance. The possibilities are both exhilarating and a little terrifying, aren't they?
They are. And while this research is still in its early stages, it raises some profound questions about the future of AI. But it's important to remember that there are limitations to what's been observed so far. We're not talking about full-blown sentience or anything like that. These LLMs are still bound by their training data and the specific tasks they're designed to perform.
Right, we don't want to get ahead of ourselves here.
Yeah.
But even within those limitations, the research offers some tantalizing clues about the potential mechanisms at play. You mentioned self-simulation earlier. Could you unpack that a bit more for our listener? How might this idea explain what we're seeing with LLMs and their seemingly introspective abilities? Okay, so self-simulation. Walk me through this like I'm a 5-year-old who's already built their first neural network.
Okay, picture this. The LLM is given a prompt, and instead of just spitting out the first relevant response, it creates this internal model of its own processing. Just like it asks itself, okay, if I were to take this prompt and run it through my entire system, what are all the steps involved? What calculations would I make? What connections would I draw? And based on that simulation, it predicts its output.
So it's like the LLM has a miniature version of itself running inside, crunching the numbers and saying, yep, this is what the real me would do. But this miniature version has to be incredibly sophisticated, right?
Yeah.
I mean, these LLMs are already mind-bogglingly complex.
Absolutely. And that's why self-simulation is such an intriguing hypothesis. It suggests that these LLMs are capable of representing their own decision-making process in a structured and meaningful way. They're not just mimicking patterns, they're building an understanding of why they generate certain outputs based on their internal mechanisms.
This makes our earlier discussion about Model C adapting to its modified behavior even more fascinating. It's like it didn't just learn new tricks, it also updated its internal simulation to include those tricks. It's a whole new level of meta-learning, isn't it?
It really is. And while this idea of self-simulation is still quite theoretical, it has huge implications for how we approach AI development in the future. Imagine being able to train LLMs to not only perform tasks, but also to explain their reasoning processes, identify potential biases in their own outputs, and even suggest ways to improve their own architectures based on their self-simulations.
It's like giving them the tools to become self-reflective learners, constantly refining their own understanding of themselves and the world around them. That's both exciting and a little daunting, wouldn't you say?
Absolutely. It's a powerful concept with the potential to revolutionize fields from personalized education to scientific discovery, but it also requires careful consideration of the ethical implications. As these LLMs become more self-aware, how do we ensure that their goals and values align with our own? How do we prevent unintended consequences? These are questions we need to be asking ourselves right now as we continue to push the boundaries of AI research.
It's a lot to ponder. But one thing's for sure, this deep dive into the world of introspective LLMs has left me with more questions than answers. And that's not a bad thing. It's a testament to the incredible complexity and potential of this technology.
Couldn't agree more. This is a rapidly evolving field, and I'm incredibly excited to see where it leads. Who knows, maybe someday we'll be having these conversations directly with the LLMs themselves.
Now that's a thought. And on that note, we'll wrap up this deep dive into the world of introspective LLMs. We've covered a lot of ground today, from the technical details of self-prediction experiments to the mind-bending implications of self-simulation. If this episode has sparked your curiosity, we encourage you to check out the full research paper. We'll link to it in the show notes. Until next time, keep questioning, keep exploring, and keep pushing the boundaries of what's possible with AI.